HTTP security headers are often overlooked when taking a website into production. In this festive tech calendar session, you'll learn how Santa improves the security of his Azure web app by following a few simple steps. You will also discover how his elves leverage free-to-use tools to both validate the changes and ensure that functionality is not impacted. By the end of the session, you should have all the information you need to start improving the security posture of your own web applications. My name is Chris Bradshaw. I'm a Microsoft Certified Azure Administrator and Solutions Architect. I spend a lot of my time designing and building infrastructure for solutions on the Microsoft Azure platform, and many of these are web applications. I have a history of dabbling in web development going back to handcrafted HTML in the 1990s, then later some .NET and content management systems. But my career led me away from dev and down the IT pro route, which is how I come to be working with Azure, and web apps in particular, from an infrastructure perspective. Security is a big focus, particularly in the modern IT world, so when designing and building out new web applications, I'm endeavouring to implement secure by design infrastructure, as well as working on a cycle of continuous improvement to existing solutions. Why am I telling you all this? Well, my journey has covered the roles with responsibilities for HTTP security headers. This is a security requirement, so the task of monitoring and enforcing them may lie with your cybersecurity team. Headers can be implemented by the hosting platform, and this is a good way of creating a standard, as I will show later, so this might involve an infrastructure team. But the application has to work with any increased security measures, and some headers may be specific to an app, and this is where the developer team is involved. These three roles, security, infrastructure and development, all need to pull together to make this work. In terms of an agenda, I'm going to start by covering what HTTP security response headers are and why you should use them. Then we're going to jump into a demo and see how to investigate the current headers, getting a baseline score for our Azure Web App hosted website. Next, we'll look at how to implement headers using this same website and see the impact of not doing it correctly. The third demonstration will show you how to check the headers do not break the functionality of the website and how to diagnose and remedy them when they do. And finally, we'll look at how we can use other infrastructure resources, such as the Azure Application Gateway, to implement headers across multiple applications. So what are security headers? Well, as you know, when you visit a web page in your browser, the server running the website returns a document, essentially your HTML, your style sheet, maybe some JavaScript, which your browser then renders on your screen, pulling in additional files such as images and video as required. Alongside this content, the server can also return a number of pieces of data known as HTTP response headers. These can give instructions to the browser on how to handle the content or provide information on the server configuration. When building our website, there are a number of headers we should implement to increase the security and some others that we should remove. Now, I'm not going to spend this presentation reading through a long list of headers, what they each do and why they should be implemented, but here are a couple of examples. The first header, Strict Transport Security, is important in instructing the browser to only use HTTPS and not the unencrypted and insecure HTTP when interacting with a website. Usually we'd enforce this at the web server as well, redirecting any requests to regular HTTP to the HTTPS equivalent. But this header tells the browser to only look at the encrypted HTTPS addresses when interacting with this website. Content security policy is another important header. This one defines where a page can get hold of, amongst other things, its styles, scripts and media. Locking this down is important in helping prevent cross-site scripting and other similar injections. If an attacker hides a reference to their script on your web page somehow, this header will prevent the browser from executing that script if it's not in the list of approved sources. This header is extremely powerful and can be tricky to implement on a complex website. As we'll see in one of the demos later on, a badly designed content security policy can stop a website working correctly. The server header is a default one that we usually want to remove rather than include. This header returns information about the web server infrastructure to the browser. For example, the version of IIS, Nginx or Apache being run. Whilst removing this isn't going to stop a determined hacker, let's not make their lives easy, yeah? If your site is telling the world it's running a version of a web server which has a known vulnerability, that just makes it an obvious target to attack. In this first demo, I'm going to show how we can check headers on a website. I've set up an example website which I'm going to use throughout this video. I'm sure with the resources at his disposal, Santa would have a much slicker site than this, but this is enough for our purposes. The website is running on an Azure web app and we're hosting it on the free tier. I will include links to a GitHub repo at the end of this session if you want to experiment in your own Azure account. This is our example site. We have a single page and there's some basic styling, including a background image and some coloured text. There's an embedded YouTube video and some JavaScript which makes the snowflakes fall down the screen. So, how can we check the HTTP security headers on this website? The website is functionally working, but as we'll shortly see, it's not implementing headers correctly. Checking now means we have a baseline to work from, and we can compare this with the results of repeat tests later on to see what improvements we have made. There are a number of tools out there that can analyse your security headers, varying from browser tools and PowerShell scripts through free websites to paid-for cybersecurity solutions. What you use is very much down to the scale of your operation and what tools are already in place. In this video, I'm going to demonstrate some of the free tools that anyone can use, either on their own or to supplement a more comprehensive security solution. To start with, let's look at the headers using the developer tools in a browser. This is the Microsoft Edge browser, but Google Chrome looks very similar, and most modern browsers will have an equivalent view. So we press F12 to bring up the developer tools. And now we want to go to the Network tab in the Tools window. There's no information in here at the moment, but if we refresh the page, it will reload all the components in this site. Now, the one we're interested in at the moment is the document page. The HTML essentially that's being rendered via the browser. So if we click on the document, we can see here it brings up lots of information about the web page. But the bit we're interested in here is the response headers section. And you can see this is quite short and quite empty. The only headers we're seeing here are the date the page was returned, the date the page was modified, and the server that the website is running on. We could implement some headers and we would see them appear here. But what if we don't know what's missing? For this, we can look at securityheaders.com. This is another valuable resource that I'd recommend. It's created by security researcher Scott Helm, and this does an analysis of the headers and not only tells us what is found, which we can get from the developer tools here, but also tells us what is missing, what's incorrectly configured, or what could be improved. So if we open that site and we put our URL in at the top and click scan, it returns a report. And we can quite clearly see we got a big red F, so there's definitely room for improvement. Looking down the report, there's a number of sections, but I'm going to focus on the one called Missing Headers. This is a good place to start. Here we find the notable security headers that are missing, a brief description of why we should implement it, and in some cases a recommended value that we should set the header to. With all this information, we know where to start. In conclusion, our baseline tells us that despite the website being functional, it is failing on a number of compliance tests, and it looks like we have some work to do. In this demo, we're going to add some HTTP security headers to our demo site. Now, headers for a site are usually configured in a config file, and this file varies depending on the hosting platform. Windows IIS uses a web.config file, Nginx uses a .conf file, and Apache HTTPD, which we're going to use in this demo, uses a .htaccess configuration file. The config file we're going to use sits in the top level folder of the site. So in a Linux Azure web app, that's /home/site/www-root/.htaccess. There may be existing content within this file. If that is the case, then it's usually just a matter of appending our instructions for headers to the end. In our demo website, we're going to be starting from a blank slate for simplicity. So here's our initial contribution to the configuration of this site. As you can see, there's a line for each response header we want to include. There's the instruction header set. We want to set the value of a header. Then there's the name of the header, so content security policy, feature policy, and so on. And finally, the value to assign to that particular header. This is all fairly straightforward. In each line, we want to set a header called something to a value. So we need to add this to a file on our web server. And to do this, I'm going to use the SSH shell in the Azure portal. But you can use whatever upload or continuous deployment methods you already have in place in your environment. The advantage of this method is that as soon as the file is saved or uploaded, the new settings are live, which works much nicer for a demo because we don't have to wait for a deployment process to run. So I'm going to open up the htaccess file in the editor of my choice. And we have a new file. I'm going to paste in the header text we prepared earlier and save the file. Next, we can go to our browser. We already have the developer tools open, and we can hit refresh. And when we select the document page, we can see that a number of response headers have been returned. To see how much we've improved the site, let's revisit securityheaders.com and see what the new rating is. We just enter the URL again, we hit scan, and as you can see, we have a much better score, an A+ rather than an F, and our site is therefore much more secure. However, you may have noticed when we looked at the site that it's not quite right. Pieces of the site aren't displaying as they should. We can't see our nice background, we can't see our font styling, or our video, or our snowflakes. As the only thing that we've changed is the response headers, it's likely that this is the cause. So in summary, our site is passing the security compliance testing, but the functionality is now broken. We've seen that if our headers are too strict, they can break the functionality of the site. So let's look at how we can diagnose the cause and what we can do to fix the site whilst maintaining that level of security. The developer tools in the browser are the first tool to use here. So if we switch to the console, we can see a list of error messages. Let's look at this embedded video. There's an obvious entry in the list here. Refuse to frame www.youtube.com because it violates the content security policy. Remember, our content security policy is telling us what sources can be used by the web page. In this case, www.youtube.com isn't on the allowed list. So we can jump to our SSH session and quickly add this URL to the list of allowed sources. This is in our .htaccess file. And we save that file, and as before, that should take effect straight away. So if we go back to the web page and refresh, we can now see it's displaying our YouTube video, and that particular error has disappeared from the console. Next in the console, we can see 3 errors saying refuse to apply inline style, again because it violated the content security policy. Now, inline styles are best avoided if we can. This allows someone to modify the source of our page in the browser with potentially unwanted results. And there are a number of ways to fix this. The best way, and the easiest in this demo, is to move the styles into a separate .css style sheet file. Let's have a look at the source code for our web page. And here we can see the 3 inline styles. There's one. There's one, and there's one. We can take these and put them in an external CSS file. And here's that CSS file. We've got those styles and we've just copied and pasted them out of them, cut and paste them out of the HTML file. And in the HTML file, we just put a reference to that style sheet. Here's one I prepared earlier. And let's open that up again in our editor so we can just have a look at it. And now we can see we don't have that styles, we've got a reference at the top, and then we've put class statements in here that reference the entries in our style sheet. This is all, standard CSS here. Now we can go back to our web page. You can see here we're still in that situation where the video is working but the styles aren't. There's no background, there's no red text. So we'll refresh, and as if by magic we now have our nice background, our red sample text all working. The final error to address is this inline handler. So this was the event that causes our JavaScript snowflakes to start falling, and as you can see there's no JavaScript snowflakes here. As with the styles, inline JavaScript and event handlers are not considered safe. In this case we have an onload event in the body of the page which triggers a JavaScript function further down. And we can see that here in the source code. We have an onload, initialize animation, and then further down here we have the JavaScript code. Now the solution here is very similar to the one we did for the styles. We want to take that code out and we want to put it in a separate .js file. So in true Blue Peter style, here's one I prepared earlier again. And now our page is much shorter. We haven't got all the JavaScript code at the bottom, that's all gone. And we haven't got the onload event here. We've just got an ID to identify that section. The JavaScript has all moved to an external file, and here we can see, this is basically the same code. We've just cut and pasted it out of the HTML file into a separate file, and then at the very bottom we've added a line here, and this line basically does that onload event for the body. So we'll go back to our site, and refresh the page again. And we've got a different error. The snowflakes have appeared. We can see them at the top here. They're just kind of stuck there. They seem to have landed on this box and they're not going anywhere. But we have some new errors. And again, this is saying we're refusing to apply an inline style because of that content security policy. Now, this is because the JavaScript we're using is inserting inline styles on each snowflake. Luckily, the browser, the console here, has provided us with a solution. So we need to put a hash in, and that should fix it. We will copy that. As you can see, it expanded there. There was an instance of this for every single snowflake. And if we go back to our content security policy, we can then insert that hash value. And we'll save that file. We go back again to the website. You can see there's a lot of toing and froing in this operation, and we'll refresh that. Nothing seems to have changed, but the wording over here is now saying that hashes do not apply to event handlers, style attributes and JavaScript. So this is a style attribute unless the unsaved hashes keyword is present. So let's go back to our content security policy and put in this unsafe hashes keyword. So you can see with this, the console is kind of guiding us along the journey to fixing this. So we'll save that again, and we go back to the web page and refresh again, and hurrah, snowflakes are falling all around. Isn't it Christmassy? All our errors have cleared. So the snowflakes, the styles, the embedded video all seem to be working as they should. However, that unsaved hashes keyword doesn't sound like the ideal fix, and we'll see about that. So now our site is functioning as we expect, we can go back to our analysis tools and see if we managed to maintain that excellent rating. We'll just hit a rescan here, and we can see we've dropped from an A+ to an A. And this is a good example of how sometimes we have to compromise between functionality and security. Santa, the business, now needs to decide if he wants to keep the snowflakes, invest development time in updating that JavaScript to work without the dynamic inline style, or potentially accept the risk. So in summary, by adding security headers and tailoring them to the website, we have greatly increased the security of this site whilst maintaining functionality. But further work may be required. In this final demo, I'm going to show how we can use the Azure Application Gateway to modify headers. If your environment involves infrastructure in front of the web server, it might be possible to use that infrastructure to implement some or all of the headers. For example, the Azure Application Gateway includes the ability to add rewrite rules, which can be used to insert the response headers and therefore apply them to all visitors to all the sites. The advantage here is that headers can be set and removed and updated on many sites in one place, and depending on your organisation, that might open up options for enforcing certain headers or separating the responsibilities for implementing them. Remember, however, how I broke the site in the demo earlier by enforcing too strict a content security policy? So applying a generic policy across the board without breaking your applications can be tricky. We can apply HTTP security response headers with an Azure Application Gateway using code, templates, or, as in this demonstration, the Azure portal. I have an application gateway set up with the custom name shown here, and the backend pool has the same Azure web app from our previous demonstration. As you can see, we have all the headers that were fixed in that demo, but I'm going to use the application gateway to remove the server header, which is currently set to Apache, and put in a new permissions policy, which currently just has geolocation and microphone in it. So to start, we go to the gateway in the portal, and we're opening up the rewrites blade. Going to create a new rewrite set. We're going to give it a name. And we're going to associate it with the existing rule. This is the rule that's connected to the one website I've set up for this demo. Now we need to add the rewrite rule itself. So we click on there, and we want to configure the first action. So this first action, we're doing a response header. We're going to set it. It's a custom header in this case. There is a list of common headers here, but this one isn't on this list. And this is permissions policy. And if we scroll down, we need to set that to a value. So in this case, we're going to add the camera in to enable that for an upcoming feature that one of the elves is going to add to our website. So here we are, camera self has been added to that. And we click OK. So that's our first rewrite rule in place. We're going to add another one. And this one we're going to remove the server header. So again, we want a response header. This time we want delete. Server is a common header, so we can find that in the list. And then we click OK. So we have our two rules, one to change the permissions policy and one to remove the server header. So we click create and we just wait for this to save. Now it's successfully saved. We can go back to our website, back on our website, and this is again the website that's gone through the application gateway, so we're not going direct to the Azure Websites.net address. And if I click refresh here, the page reloads. We can again in the developer tools, we can go to network and we can look at the list of headers. And now if we look at this list, we can see not only has the server header disappeared as we intended, but the permissions policy also has camera on it that we added. So that has the text that we put in the application gateway, and that's overridden the local headers on the web app. So in conclusion there, you can see how we've used the Azure Application Gateway, the web load balancer, to insert headers across one or more sites that are sat behind that gateway. I hope you found this Festive Tech Calendar 2022 session useful and have learnt something about implementing HTTP security response headers. As some final advice, I recommend that you get the headers in early on in new developments if possible, but hopefully the tools and techniques I've shown today will help if you're fixing existing sites. Also, be aware that these goalposts are moving. New headers will continue to be implemented, so keep your eyes out for changes. I've included a link on this final slide which has links to the resources I've used and the website used in the demo. Please check out the other sessions on the Festive Tech Calendar this month and visit their website at festivetechcalendar.com for information about the charity being supported by this year's event. Have a Merry Christmas and a Happy New Year.